Everyone, in today's lesson, we're going to talk about how to rewrite trigonometric functions as positive acute angles. So the best way I can do this is through an example. So example number 1 says, rewrite sine of 300 as a function of a positive acute angle. So let's just highlight that positive acute angle. Remember that an acute angle is an angle that is between 0 and 90 degrees. That's what the word acute means. So we're looking to rewrite sine of 300 as a function of a positive acute angle. So in order to do this, we need to do some steps. The first thing is we need to convert the angle to degrees if necessary. Well, 300 is already in degrees, so that's not necessary. So we can just say like step 1, done. Step 2, angles must be between 0 and 360. So 300 is definitely in between there, so we don't need to use coterminal or anything like that for this one. So step 2, done. And then step 3 says use quarters or for sodas, QRFS, and write your answer from the bottom up. So this technique, quarters or for sodas, will help us rewrite this function. So I'm just going to rewrite it down here. We're trying to rewrite sine of 300. So we're going to write Q, R, F, S. And we're going to figure out what quadrant we're in. Q stands for quadrant. So let's draw a picture. So we know that if this is 0, 90, 180, 270, and 360, we know that 300 is probably going to be in the fourth quadrant, right? It'd probably be somewhere in here. So if we were to graph the angle, theta would be looking something like that. Theta equaling 300. So we can say quadrant Q is 4. Fine. Next, reference angle. How do I find a reference angle in quadrant 4? Well, the real definition is how many more degrees you need to get to the x-axis or complete the circle. So we actually know that 300 plus 60 will give us 360. But if you remember the rules, in quadrant 1, angles are their own reference angle. In quadrant 2, you would do 180 minus the angle. In quadrant 3, it would be the angle minus 180. And then in quadrant 4, it would be 360 minus the angle. So if you can do it in your head, that's great, but I'd still like to see the work. So since we're in quadrant 4, we have to show that we're doing 360 minus the angle of 300, which gives us 60. Now, F. F stands for function. What function are we dealing with? Sine, cos, tan, cosecant, secant, or cotangent? Well, the original problem tells us to find sine of 300. So my original function is simply sine. Now the last one is S. S stands for sign, not this sign, but sign meaning positive or negative. So this is where we have to recall all students take calc. So we need to determine where we are in quadrant 4. So since we're in quadrant 4, that's where the C is, that means that cosine is positive as well as its reciprocal, which is secant. Every other function will be negative. So sine is the function we're speaking about, so sine will be negative. So all we're going to do now is read this from the bottom up. So we start with the negative, then the sine, and then the 60. So my final answer is simply negative sine of 60. So what we did was we rewrote this original sine of 300 as a function of a positive acute angle. It's a function because there's still sine. And now look at this 60. Isn't this 60 degrees acute? Isn't that angle between 0 and 90? Now there's a way that you can check to see if your answer is correct. So you can check in the calculator. Now, in order to check using the calculator, you must be in degree mode. If you're not sure how to get to degree mode, you can ask us in class tomorrow. But all you want to do is type in two different entries. So you're going to type in sine of 300, hit enter, and then you're going to type in negative sine of 60 and hit enter. Both of these should result in the same decimal. If they do, you know that you did your answer or you did the problem correct. So take a minute, pause the video, type these two in, and then hit resume when you're ready for the answer. Okay, so for both of them, you should be getting negative 0.86602 and then a whole bunch of other decimals. So since they're equal, you know that you did the answer, you did the work correctly. So this is my answer. I rewrote my sine of 30 as a function sine of now a positive acute angle. All right, let's try another example. So I just recopied the steps here for us to have. Example number 2, rewrite each as a function of a positive acute angle. So the first step, we need to convert the angle to degree if necessary. And we have a negative 10 pi over 8, which we know is in radians. So let's do that. So negative 10 pi over 8, we're going to remember to change to degree, we're going to multiply by 180 over pi. And when we do this, we multiply tops with tops, bottoms with bottoms. So 10 pi times 180. All you have to do is multiply the negative 10 and the 180 and then tack on the pi at the end. So that's negative 1800 pi. And then on the bottom, 8 times pi is 8 pi. You're going to notice that the pi's are going to cancel, and you're just going to divide 1800 by 8. Take my word for it that it's negative 225. So really what I'm asking you to do, so step 1, I'm just going to put a little check for that we did. So now that I've changed it to degrees, we can rewrite the problem now. I want you to find cotangent of negative 225. Okay, so now let's go back up. Angles must be between 0 and 360. And we may need to use coterminal angles if necessary. So we have a problem. Negative 225 is not in between 0 and 360. So coterminal means we take the negative 225 and we add 360 until we get an angle that works. So if you type that into the calculator, you'll get 135. So 135 is perfect. We don't have to add it again because 135 is in between 0 and 360. So we can now go ahead and rewrite this one more time, that I really want to find cotangent of 135. So I can check off that I did step 2. And then now we're going to do step 3. Now we're going to write quarters or forsotas. So with this problem, we really needed a little bit more work, ahead of time. We needed to change it to degrees, and then we needed to make it work with something that I could work with. So Q, R, F, S. So to figure out Q stands for quadrant. We're just going to draw a picture. So 0, 90, and 180. We know that 135 will have to be an angle in quadrant 2. So theta would be 135. So quadrant 2. To find a reference angle in quadrant 2, you can remember that it's just how many more degrees do I need to get to get to 180. So basically 135 plus what gives me 180. I know that that answer is 45. If you forgot, just use the rules that I put on the previous page. So a quadrant 2 reference angle, we take 180 and we subtract the angle, and you should get 45. Now the function. Well, the function that I'm dealing with originally was cotangent, so we're going to keep that going. That's my function. That's what F stands for. And then S stands for sine, sine meaning positive or negative. So we have all students take calc. So we're in quadrant 2. The only thing that's positive in quadrant 2 is sine, and it's reciprocal, cosecant. So since we're dealing with cotangent, that must mean that we are negative. So we're going to read this again from the bottom up. So bottom up is going to be negative cotangent of 45. So this is my final answer. Now you can check this one to see if it's correct, but I would use this degree measurement to check. So in the calculator, there is no cotangent button. So when you check it, you need to use 1 over tan, which is the same thing as the reciprocal. So you would do 1 over tan of 135, and then you would do 1 over tan, negative tan, excuse me, of 45. So the 1 over is the same thing as the reciprocal, right? Because if you look at your calculator, there is no cotangent button. So go ahead, pause the video, type those in, and then hit resume when you're ready for the decimal. Okay, so for both of these, you should have gotten -1. So because you got them both to be the same, that means that this was correct, and that's my final answer. All right, guys, that's it for today. If you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. All right, have a good night.